Welcome. So in the previous video, we went through the entirety of question 5 from the very beginning and we worked our way through it. We really stressed the importance of conceptualizing what you're doing and taking your time and realizing that many instances questions are linked with each other, and we just slowly worked our way through it all. The video was getting a bit long, so I stopped it. And in this video, it's a bit of an appendix, and I want to show you how you could potentially use your CAS calculator to answer the final part of this question. I'm not totally convinced that using your CAS is, in the way I'm about to show you, is the best way to do it. I think the previous video highlights the best way to go about this question, but if you are wondering whether or not you could use your CAS, this is the video for you. But let me repeat, I think that the previous video is perhaps the best way to approach this question. What I'm about to show you, some of it isn't the greatest, and the reason for that is because it's very tricky to use your CAS calculator to find an inverse function, as you're about to see. So with all that being said, let's begin. And as you can see here, what we have to do is find the area bounded by these two curves when they have the same endpoint. So if I come to my CAS, the last thing that we did here is simply just define that g of x is equal to f of x, but we've got this restricted domain, and we can quickly give this a sketch like so. So g of x like this, and of course we're going to have to add a slider in. And let me just quickly get rid of that, sorry, and get rid of that. Let me just get rid of a whole bunch of stuff not to confuse ourselves. Sorry, tab g of x. We just want to graph g of x. There it is. Let's just zoom out a little bit. There it is. Okay, so as you can see, we have a restricted domain. We can just move this up a bit. We have that restricted domain from there to there. Now, if we want to find the inverse function, there really isn't a great way to do it on the CAS. There is this really tricky, hacky way to do it. It really feels like a cheap way to do it. So if you go to actions and you go text and you just click somewhere and go x is equal to, now what we're going to do is swap those x and y's as you normally do when you're finding the inverse. And when you do that, you hit enter, then you grab it and you make it hit an axis. And as you can see, it just sketches it for you. And there you go, there it is. Now, if we are answering this last question in which we're trying to figure out where, we're trying to figure out the bounded region between these, we have to make the endpoints the same, and that occurs when a is equal to this right here. So we would end up coming here and just scrolling up to this one right here. So let's Control C this, come here, change my a value to Control V that. I can get that now, and as you can see, it's looking pretty good. And you might be thinking to yourself, great, now I can simply go menu, analyze graph, bounded area between the black line and the red line. But look, I can't click on the red line. I can't click on it. And the reason why I can't click on the red line is because the red line is a relation, and I can't use that function with a relation. I can't use the ability to find the bounded region between two graphs if one of them is a relation, unfortunately. And that is definitely one of the downsides of using this type of inverse, that you can't do it. So that means what you're stuck with is still going, all right, I still have to go menu and graph entry function, put in h of x. And then once I've put in h of x, then from here, I would have to use the same method as I did before. I would go menu, analyze graph, bounded area, this time the black line to the pink line, and then I could go from here all the way. Now let's just stop there, and as you can see here, this section right here is 0.0625, and if I of course were to multiply that by 4, 0.0625, I would get 0.25, which is my answer. As you can see here, 1/4 units squared. So that's one way of approaching it. You've got that serious limitation though of the fact that you cannot find the bounded area when you've got a relation in this case. So perhaps it just helps you to see what's going on, but there's that definite limitation there. All right, what's another way we could approach this question? Now, the next way that I'm going to show you is what I believe the MAV solutions to this exam shows. So if I was just to bring that down for a moment, this is from the MAV worked solutions. I can't show you the entire document, but I can just show you this, in which you can see that this function right here is the inverse of G. It's the inverse of G. And once they've done that, because it is a function and not a relation as you previously saw, you can use that bounded area ability of your CAS, and you can see that they found that as 0.25. So how exactly did they find this function? Well, unfortunately, these solutions don't show us how they did it, which is a bit annoying. So we're going to have to take a guess, and this is how I think they went about it. So what I think they did is they went solve, and then they went f of y is equal to x, solve it for y. So that same thing of putting the x in the y position, the y in the x position, and then rearranging it for y. Now when you do this, you're going to get something really funny out. Oh, actually, before we do this, we just have to delete that a variable, otherwise things are going to go crazy. Delete variable a. Okay, then we go menu, algebra, solve, f of y equals x of y. Okay, when we do that, as you can see, we get this one, which looks atrocious. And then we keep on going, we get another one, which looks atrocious. Then we get another one. We actually get 3 functions out of this one thing. Why is that? Well, if we come here for a moment, let's get rid of this. Let's go tab. Let's graph f of x. We're going to have to add in a slider. That is my f of x function. That's great. Look at it. It's beautiful. All right, let's get rid of that for a second. Let's come over here and let's just graph each of these functions that we're given. So here's the first one. Control C, come here, go tab, Control V, Control V. So there is the first one right there. Atrocious. Okay. Then we can go here, we can go here. Let's go grab the next one. So I just have to scroll along. I hit Shift, which allows me to highlight the next one. So I'm just coming here. There it stops. Control C. Then I'm going tab, Control V, graphing it. And now let me come to the next one. Tab. Sorry, back here. This is the final one. Control C. I come here. I go tab. I come here. I go Control V. I paste that. All right. So there they all are. Let's get rid of those. And hopefully you can see that this is the inverse of, wait for it, f of x. These are the inverse of each other. Now, why have they split it up into 3 parts? It's because I needed 3 functions. If it gave me as one thing, it would be a relation, it would no longer be a function. And then of course, think of the vertical line test, we run into some issues. So that's why they've given to us as 3 functions as opposed to 1 relation. Now, if we just get rid of this, because remember, what we're concerned about is the inverse of G, not the inverse of F. So if we come here for a second and just go tab, whoopsie daisy, tab, and let's just graph G of X. Remember, G of X is this one, and let me just move A. G of X is this one right here, the orange one. So that means this pink bit is useless to us, and this black bit is useless to us. It's the green one that is useful to us. This green one represents the inverse of G, and it is a function as opposed to what we previously did, which was a relation. So that means now, as we come here, I could go find the value of A, which means my endpoint will be the same. This one right here, Control C. Then I could come here, can come there, paste that into this part, Control V, enter. There it is right there. So now they have the same endpoint. By making that the same, now I can go menu, analyze graph, and I can go bounded area between this intersection point and this intersection point. And as you can see, I get 0.25, which is the answer. Now, do you think that's easy? Do you think that in an exam, you have the wherewithal to kind of realize that I have 3 different functions here and to graph them all out and then to pick the one that is the inverse of g and then to do it. I mean, the fact that it's only worth 1 mark means that you could just write down 1/4 as your solution, and no matter how you got it, you're still going to get the mark. But I still think that the previous video shows the best way to attempt this question. But that being said, the MAV solutions here. So if I come here for a moment, it's basically this. The MAV solution's got 0.25 using the same method as I've just shown you now. I don't know how exactly they got this inverse. I think it's the way I showed you, but they may have a better way to do it. Hopefully they do. If you know a better way, please shoot me a message, leave me a comment, shoot me an email, whatever you need to do. With that being said, I'm going to leave it there. That is just showing you some nifty CAS hacks. But again, let me repeat, I think the previous video shows you the best way to approach this question. And yeah, the inverse and the CAS just don't go together for some reason. I don't know why that ability doesn't exist on the CAS. But that being said, hopefully you found this video somewhat useful. I don't think it's that much of a useful video, but I thought I'd still make it anyway. All right, see ya.